Homework Chapter 3 review. Question number 1, which ones are valid statistical questions? 1, how many people visited Arcadia last Tuesday? Not valid. It's a fixed number. It doesn't vary. How many people visit Arcadia National Park on a typical weekday in August? So there's a number that changes from day to day to day. So that is a valid question. What proportion of soda bottles produced by a particular manufacturer contains less soda than the label? So also changes from soda to soda to soda. A bottle, it changes. So that would be also a valid statistical question. Okay, number 2, random sample of 805 U.S. residents found that the proportion of honesty and ethics of standards was as high as 85%, and that is, that's the highest profession they had there. I think doctors was up there, priests and pastors and teachers are up there too. I've seen that study before. Anyway, identify the sample in the population. Okay, the sample were these 805 U.S. adult residents, and the population, they would represent all U.S. adult residents. Okay, so the population is all residents. The sample was the 805 that were selected. Part B, do we expect that 0.85 to be exactly what all U.S. adults think? Not necessarily. It's probably not exactly. Each sample that we take will vary a bit. We think it's probably around 85%, like the sample was, but we don't know for sure what it is. Part C, how do we find the margin of error and what does it mean? The margin of error, remember we take 2 times the standard deviation, and here it gives us the standard deviation. So 2 times the standard deviation is 0.024. So what that means is we believe the true population proportion, do you think nurses are honest and so forth, to be within that many percentage points of the sample taken of 85%. So we believe it's somewhere between 82.6 and 87.4. Okay. Okay, part D says, what if we take 1,600 residents instead of the 805? So if we increase the number of people in our sample, we're going to be more accurate with our results, resulting in less variability. It's not going to be as spread out. That'll give us a smaller margin of error. Okay, so that's question number 2. Okay, number 3, we want to know, in a school of 1,800 students, they want their student opinion about the parking for students on the campus, and it's not practical to contact all students. Okay, so give a way you could do a voluntary response, which is not a good way, but a voluntary response, I said, go to the parking lot entrance, set up a table, and invite people to answer a survey. Only those with a strong opinion would volunteer their responses. Now, it wouldn't have to be this way, but describe in such a way where people are voluntarily coming up to some area to give their response. Okay, part B, how could we do it if the convenience sample? We could just ask the people coming from their cars, or just ask people within your first block class, right? So it's easy to do, something that's easily done, but it's not a good representation of the whole school. How do we do a simple random sample of 50 students? Okay, so remember the label, randomize, and select. We're going to label each student with a number from 1 to 1,800. We're going to use a random number generator to select 50 unique numbers from 1 to 1,800. And then the students assigned those numbers will participate in the survey. And why is this one better? Part D, the students are randomly chosen. It gives a good mixture of all 1,800 students. Okay, question number 4, it says flipping a disc. If it's a fair disc, we would expect it to flip right side up, half the time, and the other side the other half the time. So she flips this disc 40 times, and it lands right side up 16 times. So she suspects maybe the disc isn't a fair disc, because out of 40 times we would expect 20, right? So she does this simulation, and so this simulation we would expect around 20. So based, our center is right around 20 right here, right? But the concept first, how does it give us the idea of a variability? Okay, every time we do 40 flips, we would expect around 20 flips, but every time we do it, we're not going to get exactly 20 flips. Sometimes we might get 18, sometimes we might get 19, sometimes we might get 22. It's possible we could even get 26. We could get 16 or even 11, okay? So there's some variability every time we flip it 40 times, okay? So if we flip a disc 40 times, if it's fair, we would expect half to be right side up, but this is not guaranteed every time. Every time we flip it 40 times, we could get different results. Okay, could get different results here. Okay, so based on her results, she got 16. Does that provide evidence, convincing evidence, that her disc is unfair? Okay, so 16 happened right here. Is that very unlikely? No, it could happen. And 16 or less actually happened 12 times. So that's not very unlikely at all. So it could have just happened by chance. So getting 16 to land right side up is not that unusual. In the simulation, 16 happened 12 out of 100 times, so 12% of the time. That's not extreme enough to prove that it's unbalanced. It could have just been by how it was flipped. Okay, question number 5, have you been to the movies lately? An opinion poll calls 2,000 randomly chosen residential telephone numbers, then asked to speak with an adult member of the household. This is the question, box office revenues are an all-time high. How many movies have you watched in the movie theater in the last 12 months? In all, 1,131 people responded. The researchers used the responses to estimate the mean of the movies, how many people did. Okay, so the question, what's wrong with the question? Box office revenues are an all-time high. You want to leave that part out. That creates bias there. So if you preface a question with they're at an all-time high, it'll lead people to respond more highly. If you get rid of that part of the question, that'll make it a better question. Part B, if they're only using residential phone numbers, how might that lead to bias? Using only residential numbers leaves under coverage. Many people only have cell phones and they don't have a residential phone line and are left out. And those people with cell phones are usually younger. These younger people would most likely go to the movies more often, and so our sample is not a good representation of our population. How might non-response? Okay, there were 2,000 people that were called, and you only got a little over half of them, 1,131, to respond. So there are some who might not answer the phone or refuse to respond. This will lead to a biased result as well. Okay, number 6, how safe are anesthetics? A national study investigated anesthetics at 34 major hospitals. So if they gave them this anesthetic, they had this death rate, okay, etc. It looks like this death rate is a lot higher. Okay, it seems to be a clear association that C is more people die with that. Explain why is an observational study rather than an experiment. Okay, we can say here that subjects were not randomly assigned to an anesthetic. Without random assignment, there can be no cause and effect, so it was not an experiment. Okay, so part B, they've looked at other variables. Explain the concept of confounding in this concept. So maybe that anesthetic C might have only been used in the emergency room with seriously hurt patients. Those patients are already more likely to die. So is it because of the anesthetic that was used, or is it because of the type of patient that was used? Okay. Okay, question number 7. The teacher wants to know if student-made outlines improve performance in algebra tests. He prepares 2 assignments. One assignment gives the list of exercises from the textbook. The other, and they just do them, the other requires students to make an outline first and then gives the same list of exercises. Each of the 28 students then took the same 50-minute test and he graded it himself. Explain why he included a group that didn't prepare an outline. We need a control group. We need to compare the results. Okay, so those with and without. Part B, can this be a double-blind experiment? I don't really think so. The students and their teacher will know if they had an outline or not. Part C, identify 2 variables that he kept the same. He used the same exercises to prep for the test, the same test, and he graded them. So there's 3 different things there. We keep these same variables the same so that it reduces the variability, so the data is not as spread out, and also because it helps reduce confounding. Is it because of this or because of that? Okay. Okay. Use slips of paper to randomly assign students. Have 28 pieces of paper, label them assignment 1 and the other half assignment 2. Put them in a container and mix them. Have students select a paper from the container and assign them to that assignment. This creates equal groups so we don't have confounding variables with it. Okay, number 8, we take that same experiment, and the one group with the outline had an average score in their test of 87.9, and the other had a mean score and average score with no outline was 80.4. So part A, we want to find the difference between the two groups. So the difference was that minus that, which is 7.5. And okay, part B, is that significant? Okay, 7.5 would be about right here. So it looks like there are 4 of them that are 7.5 or more extreme here. Okay, we would just based upon chance, we would expect if there's no difference between the test groups to have some variation here, right? But if we get a difference out here, that is significant. It's not going to just happen by chance. So I wrote only 4 out of the 100, 4%, were 7.5 or more extreme. This is a big enough difference to prove that the results didn't just happen by chance assignment, but that making the outline increases a student's grade on the tests. Okay, number 9, is there a difference between reading an e-book and a printed book before bedtime? Researchers randomly assigned 12 young adult readers to read an electronic book or a printed book for the same amount of time. They found that those who read the e-book had decreased sleepiness, reduced REM sleep, and a smaller increase in blood levels of melatonin, which helps your sleep cycle. Suppose we wanted to repeat this with 50 volunteers of high schoolers. Outline the experiment. So our outline, we start with our 50 high school volunteers. We randomly assign them to 2 groups. One group we give the ebook, one group we give the printed book, and then we compare the results. Okay, part B says, what if we saw it was statistically significant? What does that mean? Okay, so it means if it's significant, we don't just get the results because of this chance, how we made these groups. There is a difference between this group and this group. Okay, it kind of proves that difference. Okay, number 10, students sign up to be subjects in a psychology experiment. When they arrive, they are told that interviews are running late and are taken to a waiting room. The experimenters then stage the theft of a valuable object left in the room. Some subjects will be left alone with the thief, and others will be in pairs. And they'll compare them to see which ones, told the truth more or let people know. Students had agreed to take part in an unspecified study. The true nature of the experiment is explained to them afterwards. Does this meet requirement of informed consent? Now, they were informed that they're going to be part of something, but they weren't informed that they were, so they did get consent, but they weren't informed exactly what it is. So they should before the experiment know exactly what is going to happen to them, what's happening. In this scenario, it wouldn't really be very hard to do and get accurate results. But it didn't really hurt people, so that's an ethical thing. What other 2 principles? Everything should go through an institutional board review. So there's a board of people that reviews it and makes sure it's good. And then also confidentiality where individuals are not being identified.